Welcome everyone, I'm Brian Walsh, and in today's lesson we're going over limiting reactants. So we're going to look at how to identify the limiting reactant in a reaction, and we're going to look at how the limiting reactant determines the amount of product that can be formed.
So the limiting reactant in a chemical reaction is the reactant that you run out of first. So let's take a look at an example to see what we mean by that. This is sort of a real-world example of a balanced chemical equation. So it says we have one car body plus 4 tires gives us 1 car. So let's say we start with 7 car bodies and 36 tires, and we haven't made any cars yet. So as this reaction takes place, in other words, as we start putting these together to make cars, these numbers are going to change. So we add 4 tires to 1 car body, and we get 1 car. We add 4 more tires to another car body, and now we have 2 cars. And the reaction continues like this until we run out of one of our reactants. And we can see that we ran out of car bodies first, which tells us that car bodies is our limiting reactant. The limiting reactant in a chemical equation is the reactant that yields less product. So the question asks, if you have 5 car bodies and 24 tires, how many cars can you make? Now this might seem really easy, but I'm going to show you a way to solve this that will work for more complicated chemical reactions also. So what we're going to do is we're going to convert 5 car bodies to cars, and we're going to convert 24 tires to cars. And whichever one of those yields less product is going to be our limiting reactant. In other words, whichever one of these makes fewer cars is going to be our limiting reactant. So we'll start by converting car bodies to cars. So we have 5 car bodies, and we look at our balanced equation here, and we see that there's 1 car body per 1 car, which gives us this conversion factor. We set it up so car bodies on bottom to cancel with our car bodies on top. So these car bodies cancel with these, and now we're left with cars. So we multiply 5 times 1 divided by 1, and we see that with 5 car bodies we can make 5 cars. Now let's see how many cars we can make with 24 tires. So looking at our equation, we can see that we have 4 tires for every 1 car, which gives us this conversion factor. And we put tires on bottom so they can cancel with tires on top. So these tires cancel with these tires, and now we have cars. We multiply 24 times 1 and divide by 4, and we get 6 cars. And remember that the limiting reactant is the reactant that yields less product, which tells us that car bodies is our limiting reactant, because we can only make 5 cars with our car bodies. And we can make 6 cars with our tires. So with 5 car bodies and 24 tires, we can make 5 cars. Now we're going to look at how to figure out how much of the non-limiting reactant is left over after the reaction is complete. So we saw in our last example that car bodies were our limiting reactant, which means we ran out of these first and had some tires left over. So let's look at how to calculate how many tires we had left. So step 1 tells us to convert the limiting reactant to the non-limiting reactant. And step 2 tells us to subtract that answer from the given amount of non-limiting reactant. So let's look at an example to see what this means. So our question says, if you have 5 car bodies and 24 tires, how much of the non-limiting reactant will be left over? Remember in the last section we figured out that car bodies was our limiting reactant? So that means we're going to have some tires left over. So our rules tell us to convert the limiting reactant to the non-limiting reactant, which means we're going to convert our 5 car bodies into tires. So we start with our 5 car bodies, and looking at our equation, we see that for every 1 car body, we have 4 tires. So we have 4 tires for every 1 car body, and we set it up so our car body's on bottom, so it can cancel with our car bodies on top. So these cancel, and we're left with tires. So we multiply 5 times 4 and divide by 1, and what we get is 20 tires. So this tells us that 5 car bodies uses 20 tires. So step 2 tells us to subtract this number from the given amount of non-limiting reactant. So the given amount of non-limiting reactant is our 24 tires, which means we need to subtract this from this. So we subtract 20 from 24, which tells us that there are 4 tires left over. Now let's look at an actual chemistry example. So this problem says, for the above reaction, how many grams of calcium oxide can be formed from 4.20 grams of calcium and 2.80 grams of O2. So they've asked us how many grams of calcium oxide can form, so how many grams of product can form, and they gave us amounts for both of our reactants, which tells us that we need to convert both of these to calcium oxide to determine which one's the limiting reactant. So we can start by converting 4.20 grams of calcium to calcium oxide. So we have grams of calcium, and we need to convert to grams of calcium oxide. So we're going from here to here. So our first step is to convert grams of calcium to moles of calcium, and we do that by using the molar mass of calcium. Using our periodic table, we see that calcium has a molar mass of 40.08 grams per mole, rounded to 4 sig figs. So we set up our conversion factor so we have grams on bottom. Now our grams of calcium on bottom can cancel with our grams of calcium on top. So these cancel, and now we have moles of calcium. So now we have moles of calcium, which means we need to use the balanced equation to convert from moles of calcium to moles of calcium oxide. Looking at our balanced equation, we can see that we have 2 moles of calcium for every 2 moles of calcium oxide. We set up our conversion factor so we have moles of calcium on bottom to cancel with our moles of calcium on top. So these moles and these moles cancel. Now we have moles of calcium oxide. So now we have moles of calcium oxide, and our last step is to convert from moles of calcium oxide to grams of calcium oxide. And we do that by using the molar mass of calcium oxide. Using our periodic table, we calculate the molar mass of calcium oxide and find that it's 56.08 grams per mole. We set it up so our moles of calcium oxide on bottom cancel with our moles of calcium oxide on top. So we cancel here and here, and now we're left with grams of calcium oxide. And since this is what we want, we can go ahead and calculate. So we multiply 4.2 times 1 times 2 times 56.08, and then we divide by 40.08, and then we divide by 2. And what we get is 5.88 grams of calcium oxide. Now we do the same thing with 2.80 grams of O2. So we convert from grams to moles using the molar mass of O2, which we find to be 32.00 grams per mole. We set it up so our grams on bottom and grams on top cancel, leaving us with moles of O2. Now we convert from moles of O2 to moles of calcium oxide using our balanced equation. So we have 1 mole of O2 per 2 moles of calcium oxide. Our moles of O2 go on bottom to cancel our moles of O2 on top. So this cancels and this cancels. And now we have moles of calcium oxide. And finally, we convert from moles of calcium oxide to grams of calcium oxide using the molar mass. We put our moles on bottom so they cancel with our moles on top. So these cancel and these cancel. And we have grams of calcium oxide. So now we can calculate. We multiply 2.80 times 1 times 2 times 56.08 and then divide by 32. And what we get is 9.81 grams of calcium oxide. And because this number is smaller, that tells us that this is how much calcium oxide we can form. If they ask us which one is the limiting reactant, we know that the limiting reactant is calcium. That's because the limiting reactant is the reactant that yields less product. What if they ask us to calculate how much non-limiting reactant is left over? Our rules tell us to convert the limiting reactant to the non-limiting reactant, which means we're going to convert 4.20 grams of calcium to grams of O2. Then we're going to subtract that value from 2.80 grams of O2. So we start by converting grams of calcium to moles of calcium. We use the molar mass and set it up so we can cancel grams on top with grams on bottom, leaving us with moles of calcium. Then we convert moles of calcium to moles of O2. Looking at the balanced equation, we can see that we have 2 moles of calcium per 1 mole of O2. We set it up so our moles of calcium on top and our moles of calcium on bottom cancel, leaving us with moles of O2. Now we convert moles of O2 to grams of O2 using the molar mass. We set it up so our moles of O2 on top and our moles of O2 on bottom cancel, leaving us with grams of O2. Now we calculate and we multiply 4.2 times 1 times 1 times 32, and then divide by 40.08, and then divide by 2. And what we get is 1.68 grams of O2. So this is how much O2 got used up during the reaction, which means that we need to subtract this from 2.80 to find out how much O2 is left over. So we subtract 1.68 from 2.80, and find that we have 1.12 grams of O2 left over.
If you have any questions about anything, or if you have any feedback that you'd like to give me, please leave me a message. You can leave a comment, or you can email me at chemistrymadeeasy118@gmail.com. Thanks for watching.